covered the understanding the definition of n factorial. Then also I introduced to you what n choose r actually means. So these are numbers that we will calculate in our calculator as well. Okay, so let's take a look at try 3. Okay. This is your textbook, page 1. So in try 3, right, they want you to find a value of n such that n choose 5 is equals to n choose 3. Okay, and this value of n must be more than 5. Okay, one reason that it needs to be more than 5 because you see that the r values are the highest it could go is 5. Okay, so our understanding of n is that it must be more than or equals to r. Okay, in this particular case, they decided to define n to be more than 5. Okay, so given that n choose 5 is equals to n choose 3. Okay, the only thing that we could do at this stage is to open up the bracket so-called, okay, by applying our formula, and that will allow us to get n factorial over 5 factorial n minus 5 factorial. And then on the right side, I'll be getting this. Okay. Then logically, okay, the next step of process is to go about simplifying this, okay, so that we can find out the value of n. Okay, so in order to simplify, what we could actually do first is possibly to remove the n. Okay, since there are n factorial on both sides, by removing, we're looking at dividing both sides by n factorial. So I'll get 1 over 5 factorial n minus 5 factorial equals to 1 over 3 factorial n minus 3 factorial. Okay. Then we could do cross multiplication as well. Okay. For the numbers 3 factorial and 5 factorial, you could actually go about pressing your calculator to determine what the value is. Okay. If you want to do that, then I think this will actually give us 6 n minus 3 factorial and 5 factorial will be 120. Okay, this is provided that you don't want to work with factorials itself. Okay, you can just compute it to find out what is the value. Right? Then, right, okay, what we could do is to put all the n's, okay, onto one side. So it's your typical solving of algebraic equations. Okay, so we will have our n minus 3 factorial over n minus 5 factorial equals to 120 divided by 6. That's equals to 20. Okay. The challenging part is to really understand what n minus 3 factorial over n minus 5 factorial means. Okay, so let's just open it up. Okay, we know that n minus 3 factorial would actually be n minus 3 times n minus 4 times n minus 5 all the way to 1. Okay, and then for n minus 5 factorial, that would be n minus 5, n minus 6 up to 1. Okay, I intentionally write it in this manner so that I want you to be able to see that I can cancel out the n minus 5 factorial. Okay, and then we'll be left with n minus 3 times n minus 4 equals to 20. Okay, and that leaves us to try to solve a quadratic equation already. Okay, so I'm going to expand it. Okay, and we get n squared minus 7n minus 8. Then factorize. We get n equals to 8 or n equals to negative 1. Okay, keeping in mind that n cannot be lesser than 5, less than or equals to 5, because the condition is n more than 5. So we reject n equals to negative 1. Okay, I think that's chapter 3. If I'm not, or is it chapter 4? Forgot already. Okay. Last year we learned polynomials. Okay, and we know that polynomials are terms such as maybe having a n x power n. For example, let's not do this, right? Okay. So for example, we have our x cubed plus x squared plus x plus on. Okay, until maybe 1. Okay. So this is your cubic polynomial, right? You can also have power degree 4 polynomial. So let's say 5x power 4 minus 3x squared plus x. It was something like that. Okay, so we have learned about polynomials last year already. So from the word that suggests, right, binomial, we know that bi represents 2. Okay, so binomial represents 2 terms. Okay, polynomial means poly, many terms. Okay, so binomial means 2 terms. That's why in binomial theorem, this entire chapter, we're trying to focus on the expansion of 2 terms. Okay, x plus y, and then after that to the power of n. Okay, so that's why it's called binomial theorem. Right, just an interesting fun fact. Okay, if you want to understand what the term means. Alright, at the very beginning, okay, when we look at binomial, okay, how do we even generate out the formula itself? Okay, we started off looking at the Pascal's triangle. So it is a special pattern, okay, that we observe in the expansion of a binomial. Expansion of, let's say, 1 plus b to the power of n. Okay, so when n is equals to 0, that means we're looking at 1 plus b to the power of 0. Okay, that means that our term is just 1. Okay, and therefore our binomial coefficient, we only got one term that is 1. So the only coefficient we're looking at is 1. Okay, now what if our value n over here is actually 1? That means we are looking at 1 plus b. Or you just put it very clearly, okay, you're looking at 1 plus 1b. Okay, the coefficient is 1 and 1, 1 and 1. Okay, if I continue down the list, 1 plus b to the power of 2, okay, we're looking at the expansion of 1 plus b squared, which we know that it is actually 1 plus 2b plus b squared. Right? Okay, to be clear, we're looking at 1b squared. Okay, then after that we see that we have 1, 2 and 1 for our coefficients. Okay, I continue to expand. Okay, n now becomes 3. Right, if I want to expand it, okay, which I can leave it to you to do it, but I'll tell you now that the expansion will be 1 plus 3b plus 3b squared plus 1b cubed. Okay, and then we will have 1, 3, 3, 1 as the numbers that we see in front of the terms. Okay, gradually as you proceed down the list, proceed down the list, you notice a pattern going on. Okay, why is it that I write my numbers this way? Okay, it is because there's this triangular shape going on. That's why it's called a Pascal's triangle. We observe that these two numbers here, okay, will add up to be 2. These two numbers here gives us 3. These two numbers here gives us 3. Okay, it always starts with 1 and ends with 1. Okay, in between is always the numbers on top. Okay, and then the sum of it. Okay, so it's an interesting pattern that we observe. Okay, from Pascal's triangle. Okay, so maybe I continue another two more rows. Go about doing the expansion. I'm just skipping away the whole expansion phase. Okay, I can leave that to you to do. But what I want you to know is that trust me that this is correct. Okay. You notice that it will always be the sum. Okay. How is this actually helpful? Okay, this is probably helpful in knowing in being able to recognize what is the full expansion without really doing the full expansion itself. We notice that in our expansion itself, right, let's say if I'm looking at power of 2, okay, the highest power will always be 2, okay, power of 3, highest power is always 3. And it goes in the increasing order, okay, from b to the power of 0 all the way to b to the power of 2. Okay, likewise b to the power of 0 all the way to b to the power of 3. So if I really want to be able to find out, okay, let's say 1 plus b to the power of maybe 47, okay, then do I really need to do the full expansion? Okay, you need not. If you know the Pascal's triangle, you can come up with the numbers, summing up will be slightly easier than doing the full expansion itself, okay, and then you will be able to know, okay, that you have to start with 1, then after that b to the power of 1, okay, for some number, I don't know lah, okay, need to do the full triangle. And then all the way to b to the power of 47. Okay, so using the triangle is kind of helpful in that manner, okay, but definitely still tedious in some manners, okay, still tedious. That's why we're going to learn a formula, okay, later on in terms of our binomial theorem, okay. Any questions at this stage? Alright, so no questions. Okay, let's move on. We'll take a look at try 4. Very rarely I would say that Pascal's triangle is being required, but I don't want to give that word of confirmation as well, because you never know. Find the first. Where they want you to use the Pascal's triangle, okay, is that it specifically say use the Pascal's triangle to find the first 5 terms in ascending powers of b in the expansion of 1 plus b to the power of a. Okay, so in my triangle earlier on, I already have up to 5. Okay, so if I really want to start from scratch, okay, what I'll do is that I know that it must always start with 1. Okay, then the next row is actually 1. So this is where n is equals to 0, 1. 2, so 1, 2, 1, 3, 1, 3, 3, 1, 4, 1, 4, 6, 4, 1, 5, 1, 5, 10, 10, 5, 1, 6, 1, 6, 15, 20, 15, 6, 1, okay, 7, sorry, running out of space, 7 will be 1, 7, 21, 35, 35, and then hang on, 15, 6, 21, 7, 1, and 8, 1, 8, 28, 56, 6, 70, 56, 7, 28, 8 and 1. Yes. Okay. So if you want to do a Pascal's triangle, you really have to come out with this. Okay. If you notice how I do it, it's really just observing the numbers on top and then do your addition. Always know that we start with 1 and end with 1. Okay. And notice that in this Pascal's triangle, there is some symmetry going on. So right down the middle, okay, the numbers are actually symmetrical to each other. Right? So now that we've gone up to 8 already, why do I go up to 8? Because the power is 8 over here. Okay, I want to find the first 5 terms in ascending powers of b. These numbers over here are already arranged in ascending powers of b. So that means that my expansion 1 plus b to the power of 8, okay, will start with 1. Strictly speaking, we're looking at b to the power of 0. Okay, then 8. b to the power 1 plus 28b squared plus 56b cubed plus 70b to the power 4. This will be 5 terms already. The remaining you can put plus dot dot dot. Okay? But you need not actually put in b to the power 0 and b to the power 1. I'm just trying to be very, very clear so that you understand how I put in the numbers over here into my terms. Okay? So the ones that I'm writing in red need not be placed as your final answer. In fact, you shouldn't put it in because otherwise your answer is not simplified. Okay? Any questions at this juncture? Okay, so you notice that using the Pascal's triangle, right, it really saves a little bit of time because what if I really want to go about expanding it? Okay, you will find that doing the actual expansion itself will actually be very tedious because, okay, what you have to consider is perhaps 1 plus b plus times 1 plus b first, and then 1 plus b to the power 6, so that there's total of 8. Okay, you can only do 2 by 2 expansion. Okay, so 1 plus b times 1 plus b, that means 1 plus b squared, 1 plus 2b plus b squared times 1 plus b times 1 plus b to the power 5. Okay, you really need to go about doing your expansion slowly. Now I got these 3 terms and these 2 terms. Do rainbow again. At this stage, I already feel very tired lah. Okay, I don't know what you all feel. You all feel tired already. I mean, just by looking at this, 1 times 1, 1, 1 times b, b, plus 2b, plus 2b squared, plus b squared, plus b cubed. Okay, this is enough, okay, for you to probably feel tired for the next one already. Okay, this one you still need a rainbow again. Alright? But of course can simplify first. Okay? I just really want to demonstrate how tedious it is if you really want to do the distributive law, your rainbow method, in doing the entire expansion. Okay? So Pascal's triangle is one way to overcome it. Right? So moving on to part 2 of this same question. In part I, okay, in order to find out what is the first 5 terms for the expansion of 1 minus b to the power of 8. Okay, this is 1 minus b to the power of 8. Earlier on we have 1 plus b to the power of 8. Okay, I want you to notice that 1 minus b to the power of 8 is no different from 1 plus negative b, then the entire thing to the power of 8. Okay, so essentially what we're doing from comparing this with this, okay, is that the original b is now going to be replaced with a negative b. So everything over here will be replaced by negative b. Okay, so this one not much of an issue since the b doesn't exist in the first place technically. Okay, so we start off with 1 plus 8 negative b plus 28 negative b squared plus 56 negative b cubed, and then plus 70 negative b to the power of 4. Okay, that will be the first 5 terms by making use of your answer in part I. Okay, then of course we got to simplify. Okay, and notice that your negative and positive signs or your operations, they run in an alternate manner. Okay? And the reason is because when it is to the power of an odd number, okay, your negative sign will still remain because negative times positive times negative will be negative, right? Okay. Expand 1 plus x squared to the power of 8. So based on our observation in part A already, okay, naturally what we'll be doing is that the b that we have over here will now be replaced with a x squared. Okay, so by comparing, I'll have 1 plus 8x squared plus 28x squared squared plus 56x squared cubed plus 70x squared to the power of 4. Okay? So this b to the power of 0, to the power of 0 means that it's 1, right? Okay, so that's why I don't put x squared over there. Okay? So I'll have 1 plus 8x squared plus 28x to the power of 4 plus 56 to the power of x, sorry, 56x to the power of 6 plus 70x to the power of 8. So this is a point where you need to remember your indices law. These are multiplication, 2 times 2, so 4, 2 times 3, 6, 2 times 4, 8. Okay? So do bear that in mind. Okay? Questions at this juncture? Right? I'll give try 5 and try 6 a skip first because actually I find that that's a special case. I want to go into 6.2, introduce to you the formula for binomial theorem. Okay, once you are familiar with that formula, it really helps you to overcome every other binomial question. Okay? Okay, we are looking in generic form, a plus b. A and b can be anything depending on what the question is. We're looking at to the power of n, okay, also in a very generic form. So what it expands out to, okay, this formula is provided in your formula list. You expand out to a to the power of n plus n choose 1, a to the power of n minus 1 b plus n choose 2, a to the power of n minus 2 b squared. And then, hang on. And then plus dot 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 plus n choose r, a or n minus r, b or r plus n choose n minus 1, a, b, n minus 1 plus n choose n, b or n. Okay, a very long formula. Let me do a quick check or something. Okay. In your formula list, okay, I want to highlight to you that they actually don't give you this one here. Okay, this section they don't give you. So they give you from a of n all the way to this n choose r, then all the way to, they will stop at b to power n. Okay. So let me just write for you what is in your formula list. The one in black is what is given in the formula list with the a plus b to the power of n. Okay, so let me help you to understand this information that's given to you in your formula list first. Okay, so this formula is a simplified, most simplified version of how the expansion will always look like. Okay, if you let's say have the n to be 2, right? Okay, so let's start with a very simple example. I know that a plus b to the power of 2, you already learned that in sec 2, it will be a squared plus 2ab plus b squared, right? Okay, how does this formula apply? Because this formula seems like it's endless, okay, because of all the dots and all that. Okay, so how this formula applies is that the n will be replaced by 2, right? So I will be getting a squared plus 2 choose 1, okay, a to the power of 2 minus 1b. Okay, then after that, next term, I will have 2 choose 2, a to the power of 2 minus 2b squared. Okay, next one. Okay, technically within the dot, it should be a n choose 3, but the thing is that my n is 2, and we know that n must always be a bigger, otherwise equal number to 2. Okay, so that's why in the purple one that I wrote, okay, the formula is telling you that n choose n is where it stops. Okay, that means that if the numbers are already the same, your formula stops there. So at this juncture, the formula stops already. There's no more dot. Okay. Then we go about simplifying, right? 2 choose 1, we press our calculator, that will give you 2ab. 2 choose 2, you can press calculator also, it will give you 1. Okay, and that will actually be a to the power of 2 minus 2 is 0, so that's left with 2, that's a b squared. Okay, so your formula application is consistent with our understanding of the very basic expansion. Any questions? You all get what I'm trying to say? No? What do you not understand? What I'm trying to do here is to show you how the formula applies. Okay? So, we already know that a plus b squared confirm give us a squared plus 2ab plus b squared. Okay? So, I know now my n is 2. What I did is replace all the n to be 2. Okay, so a squared, then sorry, I'm using this one, a squared plus 2 choose 1, okay, a to the power of 2 minus 1, b, then 2 choose 2, because n is 2, a to the power of 2 minus 2, b squared. Okay, why is it that I stop here? Why do I not go on? Because the formula is a generic form. They are telling you that when we stop the application of the formula, the moment that it is the same number already, n choose n. Okay, which over here is already 2 choose 2. We cannot have another 2 choose 3. This will not be possible. Let me see how it may be like 2 minus 3, b choose 3. Okay, you can go and press your calculator, go and give it a try. 2 choose 3 doesn't give you any number at all. Okay, it's invalid because our understanding of n choose r is being defined such that n must be greater than or equals to r. Okay? So therefore, this is not possible. Our application of the formula ends here for this expansion. Questions? Anything that you don't understand? Okay. Maybe we just need to practice a little bit application of the formula. Okay. But before that, another thing that I want to point out to you, okay, about this formula, okay, is that this n choose r is the general term formula. Okay, so this is the formula for general term. Okay, and the general term is TR plus 1. I'll talk more about it as we move into that part. Okay? Right? We need to first recognize what are the terms. Okay? This is what we call the first term. Okay? Plus second term, plus third term, and so on. Okay? Depending on what is the expansion going to be like. Okay? So, let's look at an example, shall we? 6.2, question 1. Jovia, I will prefer if your eyes are awake and your head is off the table. Okay? So let's take a look and work together. Okay, x plus 2y to the power of 4. So follow me, please. Okay, we want to expand this. Okay, maybe at your stage you still want to do it by brute force. That means you want to do your rainbow method, do it step by step. You can do that. Okay, not a problem. But if I give you a question that is to the power of 10, okay, you realize that you're wasting a lot of time just for a 2-mark question. Okay, so that's why we have to learn how to use the formula itself. Okay, so x plus 2y to the power of 4. Using the formula, okay, it tells me a plus b bracket to the power of n. I need to recognize that x is my a, 2y is the b. Okay, and then my n is actually 4. Okay, so now putting it accordingly into the formula, I will start off with a to the power of n. That means it is x to the power of 4. Okay, my r value, okay, kind of goes according to the term number, just that this one is the first term, the r value is 0. Okay, this one is actually 1. Okay, so the next one will actually be 4 choose 1. Okay, followed by a to the power of n minus 1. That means x to the power of 4 minus 1. Okay, then times b, this case will be times 2y. I want us to be very careful about how the brackets are being placed. Okay, especially when powers are going to start being introduced. Okay, so that's the second term. Right? Continue. Next one will be 4 choose 2. Okay, x to the power of 4 minus 2, 2y to the power of 2. Following this exactly. Okay, at this point, for the first 3 terms, are we clear about how I got this? Okay, now the thing is the dot dot dot. How do I continue? Okay, you need to observe the pattern going on here. It is 4 choose 1, x power 4 minus 1, 2y. 4 choose 2, 4 minus 2, 2y, 2. Okay, the numbers that continues to change and increase are these numbers over here. Okay, this is actually 1. Alright, so the next one, okay, would actually be 4 choose 3, x to the power of 4 minus 3, 2y to the power of 3. Okay, so 3, 3, 3. Right? Then the next one will be 4 choose 4, x to the power of 4 minus 4, 2y to the power of 4. Okay? 4, 4, 4. Right? And this is where we stop. Because earlier on, I've already mentioned, we stop the moment when it is n choose n. In this case, 4 choose 4. Okay? So the formula stops applying here already. Okay? That means we have completed the expansion, but then this is not yet simplified. Okay? So the challenge usually, okay, is not in terms of the application, okay, it's in terms of the simplification for most students. Okay, what do I mean? When we simplify, x power 4 not an issue. We only have x power 4. Okay, 4 choose 1, press calculator, right? You will get 4. Okay? Then x to the power 4 minus 1 also not an issue, x cubed. 2y to the power 1 is just 2y. Okay, 4 choose 2, I think, what's the number? Hang on, 24. Okay, 24, x to the power of 2. This is the part where I need you to be very careful. Okay, brackets are very important because it is to remind you that this is 2y bracket square. That means 2y times 2y. So the 2 needs to power of 2, y also needs to power of 2. Okay, so we should be getting 4y squared over here. Okay, so this is the part where I want you to pay attention to. Maybe I shouldn't use 3. Let me choose 3. Okay? Did I get, this one is 8, not 24. 6. Okay? Oh, okay, I know already. I know what's wrong. Let me just do a check. 4 choose. Yes, 6. Thank you. Okay? Then after that, 4 choose 3 will actually be a 4. X to the power of 1. Okay, I'll just intentionally write a 1 here. And then 2y to the power of 3. That means 2 cubed y cubed. So 8y cubed. Okay, again, be very careful about this part. Okay, then 4 choose 4, that's 1. Okay, and then x to the power of 0. And 2 to the power of 4, that is 16. Y to the power of 4. Okay. Any questions at this juncture? Alright? Not done with simplification yet. Okay, because we have this 4 times 2 still can simplify. You get 8x cubed y plus 24x squared y squared plus 32 x y cubed plus 16 y power. Okay? Questions? If no questions, I want you to give this a try. Okay, turn back to try 7 on page 146. I want you to expand 3x plus 2 to the power of 6. Okay, but only up to the first 4 terms. Now, give you about 3 minutes to work on it, alright? If you're still lost, please let me know. Okay, raise your hand, I'll come over to you, okay? upon application of formula, this should be what you get. Okay, as I walked around, I tried to point out, okay, to most of you about the brackets that should exist. E is supposed to be 3x. 3x is everything in total. Okay, so therefore you need to have brackets before you place the power. Otherwise, okay, you forget to actually do the expansion. Right? In fact, it is not mathematically accurate as well. Okay, if you don't put in the brackets. Okay, so all these brackets here are essential. Okay. Then after that, we go about simplifying. So 3 to the power of 6, that will give you 729. Okay. 6 choose 1, press your calculator, you will get 6. 3x to the power of 6 minus 1, that means to the power of 5. So we will have 3 to the power of 5. Okay. X to the power of 5 times 2. Sorry, I didn't calculate that. So we get 243. Okay. Then 6 choose 2, you'll get 15. And then 3 to the power of 4, 81. X to the power of 4 times 4. 6 choose 3, 20. 3 to the power of 3, 27. X cubed, 8. Because the question only wants up to first 4 terms, the remaining terms you don't need to actually write it out. You can just represent it with a plus dot dot dot. Okay? You need to put in the plus dot dot dot, otherwise it is mathematically incorrect to say that they are equal. Okay, you need to represent it with plus dot dot to tell the readers that there is actually more. But we remove that because it's not necessary in the question. Okay? Continue to simplify it. And we will get we'll get this. Any questions at this juncture? Good, huh? Okay. Now, something that I didn't emphasize yet is about how the question is being phrased. Okay. The question, in fact, if you look at textbook page 146, okay, it says to find the first 4 terms in descending powers of x. Slowly. Okay, I want us to just at least be observant about this phrasing. Okay, because it is not guaranteed that every time when you expand according to the formula, you will actually have it naturally in descending powers of x, or actually something that answers the question. Okay, but most of the time they wouldn't treat you that way, whereby they need you to do a little bit of manipulation. Okay, so just to extend this question a little bit, okay, what if, okay, the question says find the first 4 terms in ascending powers of x. Okay, so what if we have to now be arranging or expanding this for the first 4 terms but in ascending powers of x? Then how? Okay, what do we need to do? Alright, it doesn't quite make sense, okay, if I need you to go and expand everything, okay, and then after that you reorder the things. Doesn't make sense, too tedious already. Okay, what we should do is to have this observation to notice that our terms over here, so I want you to observe the A first. A starts with power n, then n minus 1, n minus 2, n minus r, and go on. Okay, and then after A disappears. Okay, our A is actually arranged such that it is in decreasing order. Sorry, let me get rid of it. increasing order. Okay, so when I was expanding this one, because my x is in the A side, right? Okay, the expansion would naturally be such that x will be in descending order. Okay, if the question asks you to do it in ascending order, what you should do is to consider instead that 3x plus 2 to the power of 6 is the same as 2 plus 3x to the power of 6. We agree that these two are equal, right? Okay, so we just have to do our A to be 2 and B to be 3x. Okay, and then expand according to the formula, and then you'll be able to answer the question. You all get what I'm trying to say? Okay, so if I were to expand this out using my formula, formula to apply to 2 plus 3x to the power of 6, right? Notice that your x is now in increasing order already. We have x, then x squared, then x cubed. Okay? So this is how we go about tackling, okay, if the question asks otherwise. Normally it doesn't, okay? Normally it will be natural, okay, fit the formula itself. But I want us to be very careful and also be aware about this. Okay? Any questions? Alright, then now let's look at, wait, what time my lesson end? Now. Okay, then we don't have time for part B. Okay, next lesson, next week, then we go into part B, alright? Okay, look, go back and then after let this digest, sink in, okay, practice the formula. Let's go.